Hi everyone, it's Mrs. Summer here to talk about Lesson 110, Compound Inequalities. The objective for today is students will be able to solve and compound inequalities, and then solve or compound inequalities, and write compound inequalities from a graph. If you recall, our answer to inequalities must always have the variable on the left side of the inequality sign. Your line and arrow must extend all the way to the end of the number line, and you flip the inequality sign when you are multiplying or dividing by a negative number to get the variable by itself. So what is a compound inequality? A compound inequality is two inequality statements such as x is greater than 3 and x is less than 8. Or x is less than -1, or x is less than 0. If you think about the and statements, x is greater than 3 and x is less than 8. So it's kind of like your parents saying, you can get French fries and a cheeseburger when we go through the drive-thru. The or statement is like your parents saying, you can get a cheeseburger or French fries. So, and compound inequalities are usually written with the variable in the middle of the two inequality statements. So here we have an expression in the middle, and there's two inequality statements on either side. To solve these, you start by breaking up the inequality and solving both and graphing the solution. So on this side, we have this inequality, and so we write it like this. And then we solve it, and we get n is greater than -10. And then on this side, we have this inequality, and we solve it, and we get n is less than 8. We graph the solution, both solutions. So first we're going to start by graphing n is greater than -10. So I've got my -10, and I will do my arrow. And then I also have n is less than 8. And I'm going to, so this whole section, and if I find my green, because red and or yellow and blue make green, this whole section is the solution. Okay, and means, and means that the solution must work for both inequalities. Okay. Here's an example, the two example questions, and I'd like you to try on your own. So question number 1 is -36 is less than 3p minus 6 is less than -15. So we're going to break up the inequality. So we're going to have, let's do blue into that inequality first. So we have -36 is less than 3p minus 6. So let's solve that one first. Add 6, and I get -30 is less than 3p. Divide by 3, and I am left with -10 is less than p. But I gotta flip it, so p is greater than -10. And now I'm going to do this inequality, and I get 3p minus 6 is less than -15. Add 6 to both sides. Let's add 6 to both sides, and I'm left with 3p is less than -9. Divide both sides by 3. P is less than -3. So now I'm going to graph my solutions. So I have p is greater than -10, so open circle, and then up through here. But then I also have this inequality, so p is less than 3. So actually, let's not color in our line until we put the circle on the other one. So is less than -3. Okay, now we can shade in the area in between those two solutions. So and inequalities will have two circles on a number line, and the space in between is shaded. So this next example, we're going to do this inequality first. So I'm left with -3. Oops, let me change those size. So I'm left with -3 is less than or equal to p over 2. Multiply both sides by 2. I'm left with -6 is less than or equal to p. But I have to flip my expression because p is on the right-hand side and I need it on the left. So p is greater than or equal to -6. And then on the next one we do, I'm going to do p over 2 is less than 0. So I'm going to multiply both sides by 2, and I get p is less than 0. So I'm going to draw my open circle here, and I'm going to draw my closed circle on -6, and I'm going to shade in the parts in between. So now we're going to talk about or compound inequalities. They're usually written as two inequality statements with the word or. So 2x is less than 10 or x over 2 is greater than 3. So you solve both and graph the solution to both on the same number line. Or means that the solution must work for either inequalities but doesn't have to work for both. So if we solve this, I get 2x is less than 10, so x is less than 5. So I'm going to graph x is less than 5 over here. And then I solve this one, I get x is greater than or equal to 6, so I'm going to graph here. So either of these solutions will work. So usually an or inequality, compound inequality, you're going to have your two arrows going opposite ways, and you'll have a space in between in which the solution does not work. So I want you guys to take your time and practice these questions. So for this first one, we'll solve this first part, so -5 first. I get r is greater than or equal to 7. And then, so I'm going to go down here and graph it. R is greater than or equal to 7. So my circle and my arrow going all the way to the end. And then I'm going to do this one. I'm going to multiply each side by 9, and I get r is less than 0. So I'm going to open circle at 0, and then draw my arrow to represent less than. So this question, I'm going to first start by adding 5 to both sides. I get 7v is greater than or equal to 70. Divide each side by 70. I get v is greater than or equal to 10. So I'm going to find my 10, and my 10 is here, and circle and shade it as best as I can, my arrow. Okay. Now on this one, I'm going to add 2 to both sides. So I get -3v is greater than or equal to 0. Now I'm going to divide by 3, -3, sorry, divide by -3. I get v, remember I have to flip the inequality, is less than or equal to 0. So I'm going to do my 0 here, and then shade in the less than